Yeah, in section 2.6, we're going to talk about how do we get the transformations of functions. And basically what we're going to look at is, up until this point we've graphed a lot of times by plotting points or by using the graphing calculator solely. This one's going to be based on the parent functions that we learned on page 202, or also the inside cover of your book. We're going to look at those and come up with how can I make a picture, how can I make the drawing based on transformations rather than relying on the graphing calculator all the time. So the first type that we're going to talk about is shifting. Now shifting means I'm going to move it either up and down, left and right. Okay, so that's what shifting is going to do. It's not going to change the physical size of the graph, it's just going to change the location. For instance, take a chair and move it to the left. Did you change the size of the chair? No, but you moved it to a different location. So that's what they refer to when it talks about shifting. The first type of shifting, by the way, and shifting happens when you add or subtract to the function. That's what it's going to do. And there's two different types, either vertical or horizontal. First one we're going to look at is vertical. Vertical shift happens when you add or subtract outside a grouping symbol. Now I abbreviate grouping symbol as GS just so that everybody knows that. But when we're talking about shifting it up or down, we're only looking outside the grouping symbol. Now, if you look at the equation and say there is no grouping symbol, then it's understood to be outside. So, if it's adding, then it's going to move it up. If it's subtracting, it's going to move it down. Okay, so those are the two different types that is going to happen with vertical. Let me give you an example on the next slide. So if I have f of x equals x squared, that's going to be my parent. Okay, and that's what I mean by the parent is that's the one that we're going to base it off of. Now in green, I'm going to make another one, g of x, that says x squared plus 3. And then in orange, I'll make h of x look like x squared minus 4 below. Okay, so again, if you notice there is no grouping symbol listed. Grouping symbols include things like parentheses, fraction bars, square root symbols, absolute value signs. All those types of things are grouping symbols. There is none of that in here, so there's no grouping symbol whatsoever. This first one here, the green one, is going to shift up 3. Now, me personally, for my students, I'm fine with you just telling me up 3. However, there's some people out there that like it as that is a vertical translation, 3 units up. That's another way of wording that. It just depends on personal preference. Me personally, I'm fine with them just saying up 3. Same thing, this one, we would say down 4. Or a vertical translation, 4 units down. Okay, so if you really want to get real technical with them, that's what you can do with them. But as far as I'm concerned, I just do up 3, down 4, and that's it. So as far as how the graphs are going to look, the first one I'm going to draw on there is going to be the parent. So the parent is x squared, which I could have got either from page 202 or the inside cover of my book, or from my graphing calculator if I forgot what it looks like. Then when I draw the green one, all I'm going to do is take this bottom point right here and I'm going to move it up 3. 1, 2, 3. And I'm going to try to make that same parabola. Now it's going to look smaller, but that's just because the window is different. Alright? It did not change the size. It hopefully was the same thing. If I were to take that green one and slide it right into the black one, it should fit perfectly. Same thing when I go down 4, I take the parent, the original one, and I slide it down. Now again, it's going to look like the orange one's bigger, but that's just because of the perspective of it. It's lower on it. If you were to slide all of them in, they would fit perfectly like a puzzle piece. Okay, so as far as vertical shifting, that's what's going to happen with it, is that all I did was move it up or down based on if it says adding, we're moving it up, minusing, we're moving it down. And that is it for vertical shifting. The next type of shifting is horizontal. Horizontal will go left or right. Now, it's going to be a little bit different with this. Left is going to happen when we, left to right, adding or subtracting inside the grouping symbol. Okay, so if you add or subtract, it's going to move it left or right, and it'll be inside the grouping symbols where it'll be located at. If it's adding, we're actually going to move it left. Now I know it looks a little bit different because usually when you say adding and on a number line we go to the right, but that's opposite for this one. And subtracting is going to move it to the right. So if I use the same parent, f of x equals x squared, and then if I give you g of x is going to equal x minus 3, notice how now there's a parentheses. Now there's a grouping symbol. That's what I mean by inside the grouping symbol. Now there is physically a grouping symbol in the problem. If there is not, then it does not have or it does not have one if there's not physically one listed. Okay, so as far as the way that this one goes, this would go according to my little chart there. We would move it right 3, and this one would go left 2. Now, according to some people, that would say a horizontal translation 3 units right, or a horizontal translation 2 units left. Me personally, I'm again just fine with them saying right or left, and that's all they have to do. So if I draw the parent again, and I do the parent just because I want to see where it came from, okay, not necessarily meaning anything else other than that. I just like to know where the graphs originated from. Now on this first one it says right 3, so this time I go 1, 2, 3, and now I make a parabola that looks exactly the same, or try to as best as possible, as the black one, but now it's just moved to the right. And then for the green one, I go left 2, 1, 2, and now it can come in here somewhere like so. So again, try not to make the graphs look any different in size for shifting. All it's going to do is just move it to the left or to the right. Now, is it possible for you to move one left and right and up and down at the same time? Yes. So if I gave you something like this that said f of x equals x minus 4 squared plus 3, that is possible to do both of them at the same time. This part right here would tell you to go move it to the right 4 units, and this one right here would tell you to move it up 3 units. So according to this, and by the way, I know my parent because of the exponent. The exponent is squared, so therefore it is a parabola. So now all I do is I move it right 3. So 1, 2, 3, 4, or 4 I mean, excuse me, and up 3. 1, 2, 3. And now that bottom point that used to be here, right here, at the origin, is now over here, and now I make my parabola. And again, I'm trying not to mess with the size as best I can, and I have it finished. Okay, so I moved everything over. What I require my students to do is not only make the picture, but then also describe what's happening. Tell me what happens. You know, sometimes the pictures are hard to do, especially when you're making homemade graphs as I am. But if you label it and tell me what happens, that's usually a better indication than of you know what's going on. So make sure that you label it. Tell me, you know, right, left, up, down, and then how far. Okay, so as far as doing both, that's what those would look like. If I gave you another one that had a different parent, x, let's go plus 3 minus 2. This time the grouping symbol is the square root, so I know that my parent actually is this. But according to this thing, we're going to go left 3 and down 2. Now I know I kind of did it in green. That was kind of a shame on me, but 1, 2, 3, and then down 2, 1, 2. That's going to start here, and it's going to go out that way. So again, they kind of look like the same thing. They're just in different locations. All right. It's kind of like if you were to have, two chairs that were in different rooms, but they're the same chair. Okay, so that's kind of the gist of it, is that I can move it to a different spot and it's still the same. So that's what it means by shifting. After shifting, we talk about reflection. Now reflection or what happens is when you flip it over. Okay, reflection and flip are kind of the same words. You actually hopefully used reflection this morning when you were getting ready, looking in the mirror. That's a reflection. Or driving. You use your mirrors to help you drive. That's reflection. Okay, you're flipping it over to see what's behind you or what's in front of you. So as far as reflection go, this is where a negative sign comes in. So if you have a negative sign in front of the x, okay, it flips it over the x-axis if your negative sign is outside the grouping symbol. And it goes over the y-axis if your negative sign is inside the grouping symbol. Now for this particular graph, you got to be really careful, because if you do the parabola and you put a negative on the inside and you square it, you start getting the same parabola. When you flip it over, it's going to look exactly the same. So sometimes it might not even show up. But let's use the parent this time to be the square root of x. So if I do, not f of x, because we don't have the same letter there. Let's go g of x is equal to negative the square root of x. And let's go orange. And h of x is the square root of negative x. Now what ends up happening is when I draw my graphs, when they flip over, let me get my graph set up here. This is the parent. And now when I go to do my next one, when I flip it over the x-axis, it flips over down here. So basically what it does is with the parent, it makes a sideways parabola. That's what the reflection over the x-axis looks like. The reflection over the y-axis would actually look like it goes out this way. Now, I had someone in one of my classes ask, is it possible to do both? And yeah, it is. And if you do both for this particular graph, then we would be down here. So we would actually finish it out and get all 4 of them if we had both of them. But I didn't give you for both. For the descriptions for these, you would say reflect x-axis, reflect y-axis. Okay, so that's what you would do there, is just tell the person where you're reflecting it over, just so that they know which way you know what's going on. So as far as reflection goes, it's either going to be on the outside, like this one is, or the inside of the grouping symbol, where that one is. So that's what reflection is. Then the last type of transformations that happen is either stretching or shrinking. Now, I like to refer to it as shrink. Some people call it compression. So I've seen it called compression before in other books. I like shrink. I don't know, they kind of sound the same when you talk about stretch and shrink, but I like stretch and shrink rather than stretch and compress. This is where you're going to multiply to the function. Now, in class, someone asked me, what about divide? Well, dividing is nothing more than multiplying by the reciprocal. So when we talk about this one, we're only going to talk about multiplying rather than dividing, because we're going to have fractions involved in this as well. So the first one that we're going to talk about is vertical. Vertical will happen if it's multiplying outside the grouping symbol. Now, hopefully you guys have now put the likenesses or similarities together. When we vertically shifted, we were outside the grouping symbol. Same thing here. When you're vertical, you're outside the grouping symbol. Now, as far as the different types go, it's going to stretch it if the multiplying number, so A, is greater than 1. Okay, that's what I refer to as the A, or the number in the front. Okay, if it's bigger than 1, we're going to stretch it. Basically, like, imagine yourself taking the top and bottom of the y-axis and pulling it. Okay, that's what it means by stretching. What's going to happen to something? You know, if you take like a piece of Laffy Taffy, for instance, if you take the top and bottom of it and stretch it up, it's going to get skinnier, and that's what's going to happen to our graphs. Is they're going to look skinnier. To shrink it, it's going to be if 0 or A is between 0 and 1. This is a fraction, okay? And more specifically, a fraction that is a proper fraction, like 1/2, 1/4, 5/8. You know, all those would be vertical shrinks. 5/2 would not be. That would be a stretch. Okay, so when they're referring to these, though, that's what it's going to look like. Now, again, if I have my parent, and we'll go back to the x squared one. Ugh, I almost did it again. G of x is, let's say, 5x squared. And let's go h of x equals 1/4 squared. So notice how there's no parentheses. It's outside the grouping symbol then if there's no parentheses. On the first one here, this would be a stretch. And we're going to also have to put vertical here. Now on the shiftings up and down, left and right, you can obviously see there's a difference between up, down, left, and right. But when it comes to stretch, there's vertical stretching and horizontal stretching. So we want to make sure we put something in there to tell you, hey, we are vertically doing this, not horizontally. So you want to make sure that you put vertical stretch, and then it would be by 5. And then the other one would be a vertical shrink by 1/4, okay, which means we're going to compress it. So when you stretch something, it should get skinnier, and when you compress something or shrink it, you're going to get wider. So on the graphs of those, you know, how you get the graph themselves, like I tell my students, you know, I know better. You guys are going to use the graphing calculator to get the picture. But as far as describing it goes, the words that I put on there would be what you would need to have. So if there's my original parabola, and I'll put the stretch one on there first. The stretch one would come in here like so. And again, if you wanted to verify that, you know, take the number 1 and put it in there. If I had 1 squared, I get 1, but 5x squared, I get 5. So instead of going up 1, I'm going to actually go up 5. Put 2 in there. You know, 2 squared is 4, but if I do it for the other one, 2 squared is 4, but then I got to times it by 5, so it'll go over 2 and up 20. You know, so it's going to go a lot faster. Raising, that is. Then as far as the 4th go, it would come in here like so. It would be wider. So that's what's going to happen when you shrink something or compress it, is that it's going to come in there wider than the original one. Okay, that's what it means by vertical stretching and shrinking. Then the horizontal is when you're multiplying inside the grouping symbol. It's going to be a stretch if the number is between 0 and 1, and it's going to be a shrink if the number is greater than 1. So if you noticed, we basically just switched the roles. Okay, and the first one, the vertical one, you know, stretch was greater than 1. This time the shrink is greater than 1. So they flip-flop there. And so how this looks, again, if I give you the parent, and I know I'm using the same parent, but I'm doing it just to show similarities. It doesn't matter what parent you use, it's still the same kind of concept. And again, if you put it on the inside. Okay, that's the important part to notice with this, is if you're putting it on the inside, what's happening. Now, if you horizontally stretch it, that's like if you grab the left and the right and stretch. Now, the analogy that I use is one of the movies I used to watch when I was a kid was Goonies. At the beginning of Goonies, the older brother was using those bands, those spring bands, trying to get stronger. Imagine you grabbing the bands and pulling to the left and to the right to get stronger. That's what this is doing. The stretching is going to make your stuff look wider, and the shrinking is going to make your stuff look skinnier. So it's the exact opposite that happens from the horizontal or for the vertical part. Now, as far as telling me what happens here, you're going to abbreviate horizontal, and we're going to say stretch by 4. Now, that's the difference with this one, is we're not going to say by a fourth, we're going to say by 4. When we report it out, we always report the reciprocal of the number that we're multiplying. So when you're doing that in the book, if you look at it, it says 1 over c. That's the same thing as the reciprocal. So when you're reporting it, you always report the reciprocal of this. Very similar to going the opposite direction when we're dealing with shifting. So this would be a horizontal shrink by 1/5. Okay. So again, that's just going to make my graphs look skinnier and wider, just like the vertical ones did. Now, as far as what could happen is, could you have all of those in one problem? Absolutely. You could have a bunch of different things happening. I'm not going to actually graph this one, but I am going to walk you through what I would look at with this. Now, what are the different pieces? First piece is this one. It's a 1. It's on the outside. It's adding. So that would be, I already said we didn't have to write that part. Way to go. Up 1. That's what's happening when you have a +1 on the outside. The next piece that's important that a lot of people forget about is the negative sign. It's outside. So that is a reflect over, not of, over the x-axis. Third piece is the 2. 2 is being multiplied on the outside. So we are going to vertical stretch by 2. And the last piece that's involved is this one. That would move it to the right 3. Now, if you take away all those different things that we just described, then whatever you have left over, that's your parent. So I know that this was a parabola. So according to this, and I told you I wasn't going to graph it, but I kind of lied. That would be the original parent. Now with our new one, if we go up 1, and we go right 3, so 1, 2, 3, up 1, reflect over the x-axis basically means it's going to open down, and we vertically stretch it, it's going to come in here somewhere like this. Now it might not be that skinny, but that's just kind of emphasizing it just so that you see what's going on. So again, most of the time, I know my students would probably just throw that in their graphing calculator to see what it looks like. It's this part that's also important to us, what's happening. So that way you kind of have an idea of what's actually going on with the problem, not necessarily just drawing the graph. So describe it, make sure you tell the person what's going on. Then the last thing that's going to ask you is the function even, odd, or neither? Now, that doesn't necessarily look at it as looking at the highest exponent and go, oh, it's even, or oh, it's odd. It has nothing to do with that. What you do for that is you plug in negative x for x and simplify. If it goes back to original, then it's even. If it goes back, or if it, that's not what goes, if it changes all signs, then it's odd. And the last part of that is, if it doesn't do one of those, it's neither. Okay? So just so that you guys know that that's the other option, is for the neither, it doesn't do even and it doesn't do odd. You know, underline even and odd so you can see them. But that's what it's asking today. When it says, is it even, odd, or neither, it's going to ask you, plug that number in. If it looks like the original, it's even. If all the signs are changed, it's odd. If it doesn't do one of those two things, then it's got to be neither. All right, so some equations that would be, so if I give you f of x equals x to the fifth plus x, and say, is this even, odd, or neither, then again, I'm going to put negative x in for x. Negative x going in there to the fifth plus negative x. Negative x to the fifth is still negative x to the fifth, and then negative x back there. All signs are changed, so therefore it's odd. Then if I go g of x, 1 minus x to the fourth, 1 minus negative x to the fourth power. Again, when you're doing this one, be very careful. This right here does not happen first. This happens first. That right there. So this ends up being negative, or 1 minus x to the fourth, which is the original, so therefore it's even. And the last one, if I said h of x equals 2x minus x squared, if you put negative x in there, again, exponents first, I can multiply the front part. It is not the original because of this sign, and it's not both signs changed because that didn't change, so this would be an example of a neither. Alright? So if they're going to ask you for is the function odd, even, or neither, then that's what we look at. In graphing, we can use that because if the function's even, it has symmetry with respect to the y-axis, which would mean if we flip it over the y-axis, we would have, or if we have half the graph, then we can get the other half by just flipping it over. If it's odd, then we'd have symmetry with respect to the origin. So again, we'd have some symmetry things, and then therefore we can graph them a little bit quicker that way. But ultimately the problems are just going to say, is this odd, even, or neither? It's not going to ask you to graph from there. So that's it for section 6.